Today's lesson 2.3.8 will be discussing graphing linear equations. We have done some graphing before, but this lesson we will be rewriting linear equations so that they are first in slope-intercept form. And then we'll also learn how to graph linear equations using the x and y intercepts. Finally, we will interpret functions from a context. Let's first look at how to rewrite a linear function so that it is in slope-intercept form, and then we will graph it. So as you know, when you have graphed linear functions before, you have graphed them in this form. Y equals mx plus b. Our b is our y-intercept, and our m is our slope. And recently we did some transformations, and we called this y equals ax plus b, but it was the same thing. So what happens when you get an equation in this form? It's still a linear equation, it's just more difficult to graph. Well, one way we can do it is we can make a table of values and we can plot the points and then connect them with a line. But another way that we can do this is to go ahead and rewrite it so that it's in the form that we want. So in this case, we will be solving for y, and you have had some experience rewriting equations to solve for one variable so that it's in terms of another. So this would be one of those times. What we would do first then is move everything next to the y to the other side. So let's get rid of our addition and subtraction first. So we will subtract 3x from both sides. We will end up with 2y equals negative 3x plus 4. Now you can put the negative 3x on the end and you can write it as 4 minus 3x. However, I'm trying to leave it in this slope-intercept form where my x term comes first. So I put the minus 3x in front and the 4 at the end. Finally, we need to move the 2 to the other side. So let's do the opposite. The opposite of multiplication is division. So we need to divide every term by 2. Remember, whatever you do to one side, you have to do to the other, and you have to do to both elements. Okay. So on the left side, we have 2y divided by 2, which leaves us with just 1y, or y. On the right side, our slope is now negative 3 over 2x. And our y-intercept is 2. 4 divided by 2 is 2. Now we can plot this function on the graph. It's easy to see because now it's in our slope-intercept form. Our y-intercept is at 2. So we would put our first point at 2, and then we would put our second point at our slope. So we have a negative slope, meaning that if we read the graph from left to right, we want our line to slope downwards. And our slope is rise over run. So we are going to go up or down 3 and go left or right 2. So I'm going to go ahead and go up 3, 1, 2, 3, and then I need to go to the left 2, 1, 2, in order to ensure that our line has a negative slope. Okay, now all I need to do is draw my line between my points, and I have graphed this linear function. All right, let's move on to our next objective. Let's graph these linear functions using our x and y intercepts. And the reason we do this is that sometimes it's not convenient to rewrite it. It may take too long, or maybe we have some fractions that are just too hard to divide. So instead, we'll go ahead and use the x and y intercepts. So the way to do that is to think of this graph. If you have the x-axis down here, and you pick any point along the x-axis, say you pick a 6, the value of y when x is 6 will be 0. I can pick any other point here along the x-axis. Say I pick this point here, negative 10. Again, the value of y right here is 0 because I'm not going up or down. I'm just remaining on the x-axis. So if I'm going to find my x-intercept, then I know that the value of that will always be 0. The value of y will always be 0. So let's actually look at that first. Let's look at our x-intercept. Okay, so we just said to find the x-intercept, that's our x, the value of y will always be 0. That can help us in this problem because all we need to do then is plug in a 0 in place of y and then solve for x. Let's do that. So we end up with 7x minus 2, plugging in the 0 for y, and then I'm going to solve. 2 times 0 is just 0, so I'm left with 7x equals 14. If I divide by 7 to solve for x, 7 divided by 7 is 1, or 1x, and I'll be left with x is equal to 2. Okay, now be careful when you do this that you write it as a complete point. So here's our point. We need to carry it down and fill in our x value. Our x value was 2. That's what we found when y is 0. So that is our x-intercept. I can plot this on the graph, and I can go over here and put a 2 here. And that's my point, 2, 0. Okay, now let's go ahead and let's solve for the y-intercept. Okay, so I moved everything over a little bit so we'd have some room. So let's think about our y-intercept. If we're thinking about this graph, anything here on the y-axis is our y-intercept. I can put a point here on 4. Think about the coordinates of that point. The coordinates would be 0, 4. I could put a point here at -8. The coordinates of that point would also be 0 and then -8. So any point here on the y-axis, we know that our x-coordinate is going to be 0. So what I would do is say that my x-coordinate is going to be 0, and I just need to find my y-coordinate. I'll do the same thing that I did when I was finding my x-intercept. I'll go ahead and plug in a 0 for x because I know that my y-intercept has a 0 for x, no matter what it is. So let's do that. So we would have 7 times 0 minus 2y equals 14. Well, 7 times 0 is just 0. That leaves us with 2y equals 14. If I divide both sides by -2, -2 divided by -2 is just 1, or 1y. So then I'm left with y equals -7. And again, be very careful that you bring this coordinate point down to describe your y-intercept, because the y-intercept is not just, you don't just say -7, we describe it as a coordinate point, and that would be 0, -7. Okay, so let's plot this point on our graph. 0, -7 is down here. And then all I have left to do is draw my line between the 2 points. And it would look something like that. Okay. And that's how you graph using your x and y intercepts. Let's try one more example. Okay, in this next example, we'll do the exact same thing. So we'll find our x-intercept and our y-intercept. So let's look at our x-intercept. We know that when we are finding our x-intercept, we will find x and we'll plug in a 0 for y. When we are finding our y-intercept, we will plug in a 0 for x, and then we can find our y value. Let's go with finding our x-intercept first. We are going to plug in a 0 for y. We will have 8 times 0 plus 5x equals -32. 8 times 0 is just 0. We will be left with 5x equals -32. If we divide both sides by 5, to move the 5 away from the x to the other side, we will be left with just 1x on the left side. So we'll be left with x equals -32 over 5. So how are we supposed to graph that? It's a fraction, and 5 does not go into negative 32. So in order to graph that, we can turn it into a mixed number. We know that 5 can go into 32 6 times with 2 left over, so about 2/5. 2/5 is close to a half, right? But not quite. But it gives us an approximation of what we need to graph. Okay, remember that we should write this, and let's move this over a little bit, as a coordinate point. So our coordinate point would then be 6 2/5, 0. I can graph that here on my graph. I will just go out to 6 and a little bit more, and I will plot my point. It's just a rough estimate, but pretty close. Now let's look at our y-intercept. And on this one, we're going to go ahead and plug in a 0 in place of x. So we would have 8y plus 5 times 0, and that is equal to negative 32. We would be left then with 8y, because 5 times 0 is just 0, equals negative 32. And if we divide both sides by 8, 8 divided by 8 is just 1y. And negative 32 is divisible by 8, and that comes out to negative 4. And I just realized in this first problem that I left the negative off here, so that would change our results here. So let's fix that. So this point should be at negative 6 2/5. So that's more like here. Okay, and then our second point is going to be at 0, negative 4. So let's plot that down here. And now we're ready to draw our line. And it's a little bit off. Let's see if we can fix that. Okay. And there we go. So that's graphing linear equations using your x and y intercepts. So if you just keep in mind that you have half of the point for each of these, and you plug it back into the equation, you'll be able to figure out the x-intercept or the y-intercept. It's very similar to creating a table of values where you plug an x in, or a 0 in for x, solve for y, and on the other one you plug a 0 in for y and solve for x. Okay, let's move on to our final objective. In this example, we will be interpreting our function from our contextual example. And it's really important to be able to do this, because otherwise, why are you learning all this information about functions if you can't apply them to real-life scenarios? So let's look at our scenario. Mila's swimming pool contains 16,000 gallons of water when it is full. On Thursday, her pool was partially full. On Friday, Mila decided to fill her pool completely using a hose that flowed at a rate of 10 gallons per minute. It took her 5 hours to completely fill her pool. So when you're reading this, your mind should be thinking about certain things. The pool flows at a rate of 10 gallons, I'll highlight that, per minute. Okay, but it took 5 hours to completely fill. So now we're comparing minutes to hours, so we have to consider that. We also need to recognize that it has 16 gallons of water when it's full. So our question here in part A is, before Mila started filling her pool, there were how many gallons of water in the pool? So we need to figure this out. Well, we know that it's 16,000 gallons is what it holds when it's full, so we can start by writing that down, that information. So we have 16,000 gallons when the pool is full. But what we want to know is how many gallons were in the pool when it was partially full. Some other information we have is that we know that it flows at a rate of 10 gallons per minute. Okay, so let's write that down. So we have 10 gallons, we'll do this, 10 gallons per 1 minute. Okay, the pool then flowed, or the hose flowed for 5 hours. So we need to convert this to hours. If we can fill at a rate of 10 gallons per 1 minute, how many gallons can we fill then in 1 hour? Well, we know that there are 60 minutes in 1 hour. And if we do 10 gallons every minute, and we have 60 minutes, we can take 10 times our 60 minutes and figure out that we flow at a rate of 600 gallons per hour. And that's going to be important to switch because we are given information in hours. We know how many hours it took to fill her pool. So when it's full, it has 16,000 gallons. Each hour, it fills at a rate of 600 gallons per hour. So how many hours did it take to fill her pool? It took 5 hours. So let's multiply this times the 5 hours to figure out how many gallons she actually put in her pool. So this is what she added. In 5 hours, Myra added 3,000 gallons. So if we take and subtract the 3,000 gallons, that can help us figure out what it started with. So this was the starting value. Okay, so let's fill out our form here. In part A, it says before Myla started filling her pool, there were, and we just figured out that there were 13,000 gallons of water. Okay, so let's write in 13,000 gallons of water. The rate at which water is being added to the pool is how many gallons per hour? Well, we had to convert 10 gallons per minute to gallons per hour in order to figure out the 13,000. So we know that it takes, or that it fills at a rate of 600 gallons per hour. Okay, let's move on to part 2. And of course we have some graphing. So in part 2, or part B, on the coordinate plane, graph a linear function that represents the number of gallons of water in Myra's pool, given the amount of time in minutes she spent filling her pool on Friday. Okay, let's come up with an equation. That's always an easy thing to do, or we can plot points, but let's start with an equation. So we know our equation is going to be in this form, y equals mx plus b. Now notice that this problem says we need to find the time in minutes, not in hours. Okay, so if we go back and we look at the problem, let's go back one page, we need to find m, our rate per minute. And it's given at 10 gallons per minute. So coming back over here, we can say, well, we know that, we know m. So y is equal to 10 gallons per minute. And x represents minutes. And you can see that label down here on the x-axis, the time in minutes. Now we need to figure out our starting amount, right, for our y-intercept. Our y-intercept is the amount of water in the pool. So b always represents the starting amount. If we go back to remember, we calculated the starting amount of gallons as 13,000. So over here, we would write 13,000 gallons is our starting value. So now it's very easy to plot. What we can do is start with our starting value here at 13,000. That's always important, is to get the starting value, to get your y-axis value. Now we need one other value. So we can use the slope, but if you'll notice that the time in minutes goes by increments of 25, which makes it difficult to figure out where 10 is and then plot a little bit more. So what we want to do is find a second point. Let's go back to our problem and see if we can figure out a second point that's easier to find. Another point that might be easy to find is our ending value. We know our Y value when the pool is full as 16,000 gallons. Now what we need to know is how many minutes is that? Well, we know how many hours it was to make it full, and that was 5 hours. So can we figure out how many minutes there are in 5 hours? Well, we know that, as we said before, there's 60 minutes per hour. So if I take 5 times 60, I know that's 300 minutes. So I'm going to use this point, 300 minutes. It's going to be 16,000 gallons, and I'm going to plot that. So coming over here, you'll notice that there is a 300 minutes, and at the very top here, we have 16,000 gallons. So now I have 2 points that are somewhat spread out, easier to graph, and I can just plot my line between those points. Another way that you could have solved this, because there's not always one correct way, after you plot your y-intercept, it might be easier for some of you to go ahead and make that table and find another point. So remember that in our table, we need x values. Well, our first x value was our y-intercept, so our x value was 0. And our y value was 13,000. I could pick any one of these numbers, anything. I could pick 100, and I could put that in there. I could pick 200 and put that in there, or 300. I could spread it out any way that I want to. So if I were to have picked the 300, all I would need to do is plug 300 into the equation, and you would get y equals 10 times 300, and 10 is always a nice number to multiply, plus the 13,000. 10 times 300 is 3,000, plus our 13,000, and that leaves us with our 16,000 that we found from the other page. So we know that at 300 minutes, we have 16,000 gallons in our pool. And that concludes our lesson today on linear functions. So let's just go back and make sure that you all understand all the objectives that we went over. So you should be able to rewrite linear equations in slope-intercept form to make it easier to graph. You should also be able to graph linear equations using your x and y intercepts. Okay, so plug in a 0 for y to find your x, and plug in a 0 for x to find your y. And then finally, we interpreted a function from a contextual example. And that is important because that, again, helps us use our math in real-life scenarios. And that's the conclusion of this lesson 2.3a.